Welcome everybody. I'm Jason. I'm the session chair today. I'm here to introduce two of my colleagues and friends, Matt and Heather. Matthew Avery, Heather Whiten. Um, Heather is IDA's Director of Research Quality and Chief Data Officer, where she provides leadership, management, direction, and support for IDA's data strategy. Heather has a PhD in experimental psychology from Marietta College, which, did I say it wrong?
University of Toledo.
I copied that out of your bio. University of Toledo. And she has applied that at IDA since 2015, starting in IDA's Operational Evaluation Division, where she served as a researcher, project leader, assistant director before her current role as director for what I said previously. Matt is one of OED's assistant directors, Operational Evaluation Division, and a project lead for the sustainment group in that division. He is also the deputy director, serving with Heather, of Research Quality and Chief Data Officer.
If you are hoping to learn about data management, you are in the right place. Otherwise, you have come to the wrong room. We are going to be learning about how to construct data management plans today, and Matt's going to mostly take you through that piece, and I'm going to talk to you a little bit more about the motivation for why we care about doing good data management in the first place. So hopefully at the end of this, got to clean up a couple things here, but we hope that you'll be able to think about how data is defined and what data management is, why they're important, understand the data lifecycle and how that relates to the research process, or in many of your cases, your testing process, your test design process, and understand expectations for data management more broadly. We've doubled this as our IDA internal training, so that's why it says at IDA. Understand what a data management plan is and the different kinds of topics that you should think about when you think about data management in the first place, how you can use those to build out a data management plan. And we'll have an exercise where we get out of our seats and build one together. Okay, as promised, what is data? Well, there's not wide agreement on that. I can tell you that within IDA, which is not that big of an organization, it took us eons, it feels like, many months to agree to a definition. But here are just a few that I stole from other places. So 2 different dictionaries from the academic literature, and then from one of our sponsoring organizations, NIH. And you can see that they're all a little bit different. Some are oriented towards a particular use case, others are sort of wide open. And so I think it's probably more instructive to think about examples of what we mean when we say data. So I tried to put those up here on the right-hand side. We mean things like your reports, memos, policies. We mean things like scripts and spreadsheets, notes that you take out in the field. They could be questionnaires or slides or transcripts, code books. They could be genetic sequences. They could be instrumentation, output collected from instrumentation, algorithms you develop or use. They could be basically anything that's an input to your test design or research process, and anything that happens as part of that process, as well as the outputs. Questions? It's pretty broad. Okay. So at IDA, we went back and forth about this for a long time, as I mentioned before. Oh, look, our distinguished guests, Bob Sewell and Dean Thomas. Welcome. And this is where we landed. So we are defining here at IDA data as any original or derived information acquired or received by our staff that could be used in the course of our business. So think there about financial information, could be HR information, anything about how our uh, how our company operates, as well as our internal publications, training, or analysis products. So we're a research institution here supporting national security. So we do a lot of internal publications and research and training of our staff. All of that would be considered data, along with any external sponsor products. So we do a lot of thinking about, for example, test and evaluation concepts. How should different military systems be tested? So all those concepts would fall into this category along with anything that we used to generate those in the first place. So we're taking a pretty broad approach to what is data here at IDA. So data management then is how we think about getting data, organizing and structuring that data, where are we going to put it, who should have access to it, as well as how do we preserve it. So, for example, we might be able to reuse it for other kinds of analyses or purposes. So that can include lots of different kinds of activities. Some of them I know will really excite you, like naming files. But also things like data privacy. Who should get to see this kind of data? So think about things like PII. So I worked on a project, for example, where we were working with student pilots. So we knew who those pilots were. We observed their performance over time. That's a privacy concern, right? So how are we going to deal with that? How do we store data? How do we curate it? Documentation so that other people might be able to actually leverage the work that we've done outside of our own team. And of course, metadata, both the creation and maintenance of it. As you'll learn from talking to me, metadata will save the world. And then importantly, publishing, sharing, and reusing data, which is something that is of great concern to me, but I think also a growing concern within the Department of Defense. As we've introduced all these different CDOs and CDAOs across the organization, NASA as well as a CDO, and thinking about how we can take data, make it an asset, make it reusable for future purposes is really important. So I just wanted to give you a couple of examples about why we care. Yeah.
What's the CDO?
Ah, Chief Data Officer.
Thank you.
You might also know them by other names, like Chief Analytics Officer, Chief Digital and AI Officer, Chief Data and AI Officer, Chief Data and Analytics Officer. There's lots of flavors to this, but that general position is finding its way into government agencies. And we'll talk a little bit more about why here in a second. But IDA has been motivated internally to care an awful lot about how we manage data because it helps us be more efficient in how we do our research. So this is an example of one of our projects. I really want to move away from the microphone, so I'm going to. Sorry, people online. So this is a project about sustaining different military systems. And as you might imagine, there's lots of data sources. So you can look at each one of these. We sort of anonymized it here for the purposes of this tutorial, but each of these boxes is a different data source that exists that contains information about spare parts or other sustainment information about one particular system. And they're all distributed, they're all owned by different people in one of the services, and it took us years to put the Lego pieces together to find all of that data. Once we had done that, though, we were able to take all of that data and create an automated pipeline, right? We were able to clean the data, curate it, automate that process so that now we're able to churn out analysis related to the sustainment of that system in a couple of weeks instead of a couple of years. And this is huge, right? This is the value for the department, being able to do that kind of thing. It's also the value that we see in it as an institution. And that's primarily quantitative data, but we're also able to do it with other kinds of things too. So documents, a lot of people don't think about documents as data, but we think about them as data. So this is a picture of Bob Sewell, who just walked in over there. This is what his desk looks like. He reads lots of documents. But lots of our folks do research where they're sifting through large numbers of policies, regulations, doctrine, ops plans, all kinds of things that are written documents. And we're able to compile all of those together into one place and then use algorithms. We have a couple that we've developed here, but these are basically natural language processing kinds of algorithms that can help us go through those documents in a more efficient way, right? So if I'm looking at a particular topic, let's say I want to understand the evolution of the requirements for the F-35 over time. Maybe I could take requirements documents and feed it in, and along with a bunch of other documents I have for F-35, and then be able to just pinpoint only the relevant information for my analysis. Right? So there's a lot of efficiency to be gained. So that's the value, I think, from the researcher or the tester's point of view, but there's also motivation coming from the federal government more broadly. So some of the biggest reforms in the federal government are happening now, and they're related to data. So it touches every federal agency that exists, and also many of the state governments are getting involved in this too. We have now a federal data strategy. We have law that says a CDO must exist in every federal agency, and so if you're in DoD, you've seen the proliferation of this. We have the Chief Digital and AI Officer, we have CDOs or CDAOs or CAOs in each of the services, and then down inside the services, we also sometimes have CDOs, CDAOs, etc. We're also starting to see policy come out across the federal government talking about the need for data management plans and better management of data. And since DoD is really important to us, thought I'd flash one of those slides up here. So DoD in particular, they've put together a data strategy. They've connected this directly to our ability to fight and win wars, which I think this is a major challenge for the department. And if we can get all of our data managed well, it will be a huge advantage for us because others are struggling with this too. We've stood up, as I said, CDAO in OSD, and we're putting out all sorts of policies. This is one which I'm not sure anyone has read. There's a DoD instruction that was put out well before CDAO existed that applies to all science and technology programs, including basic research, applied research, and advanced technology programs that require data management plans. I think that would affect the test and evaluation community. Beyond that, in the last month, the CDAO has put out guidance on metadata for the entire department. So each data set that's owned by an organization will be responsible for applying metadata to that data set and registering it. And we're more than happy to send that out if you haven't seen it. But folks like DOT&E are already thinking about how this will impact the way that they do business. Okay, so that's a little bit of the motivation, I think, from the analyst perspective, as well as, you know, from the federal government as a whole. One thing that's really important to consider as you're thinking about data management is how data actually flows through your organization, right? Or your test program. And at IDA, we went back and forth about this for a while, the same time we were defining data. And this is where we landed in terms of how we view the data lifecycle here. But you may have a different view, and your process may look a little bit different than this. But the way that we think about it is that we have this sort of bottom part of the figure, which is really the foundation for data management. And then the top is about analysis and how that feeds into additional data. So we plan for data management. Okay, we have a project, we have a program that we're testing. We're gonna think about the kinds of data that we might acquire as part of that test program. At some point, the test will happen and we will actually acquire data, we'll actually get it, and then we will have to store and maintain it somewhere immediately, right? If we're gonna keep it, we have to have a place to keep it and a plan for keeping it. At some point later, we never do this here, but maybe you guys do, is thinking about retiring data. So that can mean lots of things. That can mean archiving data. It could mean destroying it or returning it, depending upon what particular use case you're thinking about. So at any time then, between when you get the data and when you retire the data, you can leverage it for analysis. So you can pull data out of storage, you can prepare it for analysis, that is, curate it, clean it, etc. You can actually analyze the data, create visualizations so that you can interpret that, and then report on it. Then all that raw data you use goes back into storage and maintenance, along with any artifacts that you created along the way as part of your analysis and the products that you created. Those all get added then to our data holdings. So that's how we're thinking about data here. And it will be important for you to think about that for your test program. How do you actually leverage data? What's the life cycle of data look like? Okay, I'm gonna stop. If you have questions for me, I'm happy to take them now, and then we're gonna jump into the fun stuff. Hopefully you feel motivated that the federal government is telling you to manage your data better. Yes, Pat.
So I think you mentioned reproducible research in your talk, and I just wanted to give you an opportunity to elaborate on that a little bit, because one of the things that I think is really important in the test community is that we always get it right. And part of getting it right is having some people, other than the ones who did the analysis, take a look and with a fresh set of eyes and make sure there wasn't a mistake.
Yeah.
Maybe just a stupid mistake in the coding of the data,
Yeah.
or the arrangements of the data. And it seems to me that these practices are important for allowing people who weren't involved in the original analysis to be able to do those checks.
Yeah.
Can you talk about that a bit?
Yeah, absolutely. Well, we'll actually get to this as part of our example in just a minute. We refer to that as reproducible research on the whole. And that means basically, to the extent possible, that we would be able to go from our raw data set and replicate every operation that was done on the data in order to reach some particular finding. And we have here an internal process that's sort of similar to peer review in the scientific community. We call it technical review. And we want our technical reviewers to have the opportunity to be able to recreate and understand all the decisions that were made as part of that analysis process. In the scenario that you'll see here in a second, we've given the suggestion that perhaps a contractor has come back to you, has come back to, for example, the Air Force and said, we don't agree with the analysis that you've done, the evaluation that you've provided on the performance of the F-35. We're going to dispute that. And reproducible research practices and data management will help you justify why you've made those decisions, right? Why did we decide to exclude a particular data point? Why did we decide to do an analysis like this? And you'll just be much better prepared for answering those questions than you would be otherwise. And sometimes this can happen years down the line. But yeah.
What exactly are you including in your metadata, and why is it going to save the world?
Well, your metadata should include anything that you think would help the data set be more useful to someone or yourself in the future. So basically searching, right? That's the primary purpose of metadata, it's discovery. Can I find this again? So what that looks like for your data set will differ, right? But otherwise it sits in a corner or on someone's personal drive or in some shared drive that just goes to rot and die, right? Sorry, is that not a great way to talk about it? That's what happens. And so the idea is that given the right metadata, we would be able to leverage the work that we've done before so that we don't have to, for example, run another set of test points that we've already run on this system in the past. Any other questions before we jump into the scenario? Yes.
So in the slides you showed that you are centralizing the data, everything is being dropped into the central location, but the current trend is to actually have the data in a distributed fashion and expose them as a service where the domain experts are actually the owners of the data, and that data is in real time consumed using data as a service. So is there any plan to adopt these latest technologies into this architecture?
Are you referring to the data lifecycle slide where I had storage and maintenance?
Yeah.
So that is kind of just a conceptual idea. Actually, what we're doing here at IDA is exactly what you described. Is we have a distributed approach, and then we have an enterprise model that will help us discover where that data is across our enterprise. But it is not all stored in one place.
Okay, so the ownership of the data lies with the domain operations people, or it is coming to the IT centralized systems?
It depends on the particular case that we're talking about, but we have a distributed model internal to IDA. The departments, at least I think in OSD, I think this is a point of inflection for them, right? So I think the original, if you know Adana, I think the original idea behind Adana was we're going to dump everything into this pot, and then everything will be there, and then we'll be able to use it. And that's good as far as it goes. There are a few drawbacks to that, which is just dumping everything in there doesn't make it useful, right? It's disorganized and hard to use because there's no architecture, but also it's a cyber risk. So I think this is kind of an inflection point for them. And the services all have their own approach, and their CDOs are approaching it in different ways. So it'll be interesting to see how it shakes out, but we are taking a distributed approach.
Thank you.
Matt, okay, fun part.
We'll see. Okay, so the rest of the session, we're going to get a little more interactive. We're going to ask you to go through the process of building a data management plan. So, but before we get to that, I'm going to give you a little bit more context on what a data management plan is and looks like. So, we view data management plans as the critical step for managing data on research projects. The act of planning, writing things down, documenting how data will be managed for a project is vital. So in our conception, a data management plan is a living document that initially describes the plan, but then describes the execution of that plan, of how data are going to be acquired. So whether you're receiving data, generating data as part of the project, how it will be stored, to the point of the discussion we just had, what metadata you're going to collect. Heather talked a lot about metadata for discovery. Metadata for context is also important. It's not just that you can find the data. In my mind, it's also important that you be able to understand what the data actually says and what it doesn't say if you're going to appropriately reuse it in the future. How data is going to be archived, and who can access data. Security is another point that we touched on earlier. We'll talk about that more. And then identifying primary points of contact. So who is that ownership? Who has that responsibility for the stewardship of the data moving forward? In our approach, we sort of break these into different, we call them practice areas, which you see below. The aspect of planning, that's the data management plan. And then within the data management plan, how are we going to secure data? Defining the metadata we're going to collect, and then collecting that metadata, how data are going to be organized within a project, and then ensuring reproducibility. And then at the very end, we may get to touch a little bit on archiving. So we're going to walk through the process of thinking through each of these practice areas, actually trying to document stuff. You'll generate examples. We'll show you some examples that we think answer the mail for some of these. And we're going to do it in the context of a case study. So the next slide I'm going to show you is a case study. But before we get to that, I want to just have a quick pause. And I'd ask you to assemble yourselves into small groups, about 2 to 5. Feel free to meet a new person if you want to make a friend. And grab one of the handouts, which are along the side there. There's also a couple right behind there, along with a big post. You don't need a whole pad necessarily. You may just need one big sticky note for your whole group. So get something to write with. This is where you're going to be building your data management plan. So you go ahead and form those little groups now. If you need to take a break, quick bio break, do that in the next 2 minutes, and we'll get started with actually building our data management plan. All right, has everybody got a group? Excellent. So with your groups, we're going to look through the following scenarios. So I'll just give you a brief explanation, then we'll start talking about each of our practice areas. So the scenario we're working with is you've been assigned to study a new Mars rover for NASA. NASA has a new manned rover that they're going to... Perfect. Perfect. Well, this one has a new improved communication architecture, so you're going to have to work with the new communications tools. It's a manned rover, which may be a little different from what we've seen in the past, what they saw at the Air and Space Museum. That was my closest contact with one of these. The astronauts are going to employ the America to traverse the terrain on Mars. They need to be able to communicate and survive in all the different weather conditions that you'll experience on the red planet. Key research questions that you might encounter when looking at this is, can the system perform its mission effectively? Can it support crew habitation? And how does NASA intend to employ this system, and how should they, given the limitations that we might discover over the course of testing? So to do this, we got to build our data management plan. Yeah. So when we think about data management planning, these are the types of questions we want to ask and we want to address in our data management plan. So first and foremost, who's your data steward? This doesn't have to be a single person. You may have different people in charge of different data sets, but best practice is to identify a single point of contact for your data set so that people who want to ask questions about it know who they should go to. You want to have a belly button for your data. How are you going to be getting it? That includes both whether you're going to be building the data yourself, as well as the transmission mechanism that you may have to account for. Where is it coming from? Is that going to require any special access or any special infrastructure to get? How are you going to use the data? What tools do you need? That includes like hardware, software tools that you might need to store the data or to analyze it. Maybe there's software licenses involved. And then any ethics concerns that you need to mitigate. In our line of work as an FFRDC, we try to make sure there's no conflicts of interest, but that's something that everyone should be aware of. We also think about ethical concerns as they relate to the nature of the data themselves. So is there anything sensitive about the data that we would want to protect or make sure is not exposed? So for your scenario, well, here's the scenario we're working with. So NASA has an event with 24 astronauts. They're going to collect the following types of information. All the blue slides you'll find on your little handouts there. So if I'm going to zip through these kind of quickly, you'll have that information there. You're collecting data on calls and transfers. You care about the speed of the vehicle. That's collected through special sensors that require some unique software to process. The availability and reliability of the system, how easy it is to interchange different modules. The system has different modes, and it's going to be converting back and forth. You're going to collect information on that from surveying the crews who are testing the system. And then you have error rates. So for example, to collect certain subterranean samples, someone has to operate a little drill to get in there and do that properly. So can they actually use that, or are they causing system faults when they're doing it? NASA's providing additional data unrelated to the testing events, including data on past performance from older rovers, which, good on you for keeping that. Employment concepts, so how are they employed in the past, and then modeling and simulation data, which again requires some specific software to be able to process. So given all this information, what we'd like you to do is with your small groups, work to describe in the what would be the beginning of a data management plan, the data you need to acquire, information about how that data will affect the resourcing you need for your project. Again, we're in the planning stage. So what resources are you going to need to properly exploit these data, how you're going to use it, and how you're going to mitigate any potential ethical concerns associated with the data. So you have the scenario, go work with your small groups, take about 5 minutes to discuss it. You may not be able to get to all of these topics, but try to tackle at least one or two. And Heather and I will circulate to answer any questions you might have. All right. I hate to cut this discussion short. I know there's a ton of questions that we've asked you, and I know you only have a limited amount of time. So let's go through them as a group. We want to get through the whole thing today. So So we gave you a pretty good description about data you're expected to acquire. So how did you guys process that? How did you put that down in your data management plan?
What kind of data are you going to get?
You want to go or should I?
All right.
We're
Super
going to
group.
get
Go.
3 types of data: structured, semi-structured, and non-structured. Unstructured.
Okay. So those are 3 types of data. What will the actual data be?
So for unstructured, some of them might be like your common picture files,
You're going to get imagery data, maybe.
images,
audio.
Yeah, we're collecting the communications. Recall, we're collecting the communication transmissions.
Semi-structured, if I understood this right, it's information from the actual system itself. So that could be like distance, battery life.
So say for instance, if I had like a spacecraft, right, I'm going to want to have some sort of digital model of that spacecraft, right, that's going to relay the health and status of various components. That model is probably going to be object-oriented in its nature, right, not flat. So that's what we would stream over 5G to a NoSQL database as our semi-structured data. And then our structured data would be simple things: personnel, their names, MD5 hashed, so that we're taking care of any ethical considerations.
Very good.
What are their ages? What are their zip codes? The names of their pets.
So, for example, we might put down in our data management plan that we're going to collect modeling and simulation data about the system. We're going to note if it requires any special tools to process. So some of these things will require proprietary software. So we're at the planning stage. We need to budget for that if we can, right? If we know we're going to have data coming off the system that requires a special tool to process, we're going to want to get that. Depending on how we're collecting the data, we may need to think about the storage volume that we'll need.
Like if you had 1 terabyte, for example.
Yeah, maybe that's a lot, depending on your type of system and depending on the classification level you're working at. So you're going to need to budget for that. You're going to need to think about that. And then when we talk about human performance data, we may have concerns about making sure that data is stored on you may need to store it on a separate system because it's PII. You may need to put special safeguards in place to mitigate concerns about that data. So those were some points there. So did anyone have anything else that they put down on their sheets? Feel free to jump in.
So you can also mention about the ETL process, like do you want to load straight away or you want to do any transformation while you are going to store the data?
Sure. That's something you can definitely include on your data management plan, particularly as we start talking about data acquisition and how that process is going to go. That's where that would fall in, I think, in terms of how you're getting it. So one thing you might think about is those data that NASA had on historic modeling and simulation. So there was a lot of data there, right? How are they going to deliver that data to you? Does that data have any special handling instructions or special handling concerns associated with it? Maybe that's too big of a file to just send over in an email. Yeah. So you may need to think about how you're actually going to be able to get that data onto your servers, or if maybe you don't need to put them on servers, maybe you're going to use a cloud service to store and process that data. So thinking through those questions and concerns. So we took a shot at this. This is one way you might populate elements of your data management plan to discuss these issues.
So you can get far more in the weeds than this.
Yeah.
But
given that, at least in my experience, the T&E community hasn't always crafted data management plans. This is a good starting place. So naming your data steward in the first place, right? A belly button, who's responsible. This is Harry Potter, Hogwarts.org. And you don't have to list everything in narratives. Just constructing a nice table is a great way to go here. You might have these different data sets. So we said we were going to get effectiveness data. We were going to get survey data from our 24 astronauts, which we found somehow. We're going to get some human performance data and M&S data and some employment concepts. We might want to know where that data came from, the size, and whether we need special software, because that's going to affect our resourcing, right? We're going to have to account for what the cost of that is so that we don't get a nice big surprise when we're trying to deal with terabytes of data and we never thought about how to do that. And then thinking about where we might be storing that information. So in some cases, all you might have at your fingertips is a shared drive. So where on that drive are you going to put it? In other cases, you might have access to other things like SQL databases and graph databases and the like. So, but where are those? And you're going to want to list those out. And then there will be some narrative here. So, we said our software is going to cost $100 for each license. That hardly ever happens. We're going to use R to analyze our data, which is free to us, so we don't have to resource too much for that. We're not remaking the wheel on our human subjects documentation. So we have human performance data, we have PII data. You can write out what the process is to deal with all of that data in your data management plan if you want to, but there are existing procedures within the department. Here at IDA, we have existing procedures for how to deal with that. So we're not going to write all of that in here. We're going to link to those standard procedures. We're going to say these are the research questions that we're going after, and at the very start, this might be all you know. And you'll update that and add more detail as this thing grows and you find out more information and you learn more about what your test is going to look like and what data you'll have and the nature of it. So this is kind of a good skeleton, and then you can build out from there other pieces of information that are interesting.
And I think that one of the key takeaways here is not to let the unknowns prevent you from getting started with your planning process. So if you don't know what your ETL pipeline is going to look like, if you don't know that you're going to be receiving these data over 5G, that's okay. It's not a failure if that information isn't in here because it doesn't exist yet. That's why it's a living document, so that you can update as you start learning that, as those facts are established and you start understanding that.
So what about like considerations for onboard data reduction, right? To optimize, the use of limited bandwidth. So you can think of like, astronomers kind of agree how much time they're going to look at black holes or supernova or whatever, right? I'm not an astronomer. There's only a limited number of hours each night, right? And so they come to some sort of democratic agreement as to how they're going to divide time, right? So now if I'm a systems engineer, right, I'm going to care about the temperature of my circuit, right? But I'm not. I'm an operational tester, so I want the high-level tactical performance data, right? So in a similar way, we're going to have to come up with a plan to reduce that data, make sure that we're getting, the data that folks need for a variety of purposes.
And that's a great example. As you start hashing out those details and figuring those things out, you want to document them in your data management plan, both so that everyone on the team understands the plan moving forward, but also so you have documentation of those decisions that were made. Because oftentimes we have this big chunk of data. Oftentimes you may not need all of that. And if it is costly to get that data to the system, maybe it's a lot more cost effective to only take 100 gigs of that data. Then you want to document why and how that process is going to work.
Well, it's harder than that even, right? Because I'll come back to like the astronomy example. If a neutrino detector halfway around the world all of a sudden sees a huge influx of neutrinos, then I'm going to want to point my satellite at where that supernova just happened, because I'm about to be able to capture the light from it, right? And so in a similar way, if the system starts to deviate from expectations, starts to show some sort of error, failure mode, right, then I'm going to want to shift dynamically what data I'm collecting to focus on that.
So I think that as your test progresses, as your concept for that test and your design for that test matures, this will change, and you will document those decisions. But as a starting point, you're not going to have all that information at your fingertips. You might be able to have a skeleton of what you might do and how you might begin to make those decisions. Some of those things will unfold in real time, and you'll end up documenting those. But we have a lot of sections, so we want to run to the next.
Sure.
thing.
So we've thought a little bit about what data we're going to get. Let's think about how we're going to secure that data. I think for everybody in this room, data security is a key concern, key thing we think about. So as we think about how we're going to incorporate data security into our data management process, we need to think about who is going to need to access the data, how we're going to make sure that those people can access the data and that people who maybe aren't on that list are not able to access that data. We want to think about any, for the DoD classification, but more generally handling restrictions of the data. Are there any specific rules and regs that we have to comply with? Obviously for, if you're part of an HR department, that's a big deal. If you have any sort of compliance issues that you need to be aware of, that needs to be part of the process. So for example, if you need documentation, if you need to be able to document that your data is secured properly, that's something you should think about as part of your data management planning. So who can access the data, whether there's any handling restrictions? These are the questions we want to ask. For our scenario, we have just a description of what the project team looks like. So we got 3 researchers who are analyzing the data. We have another researcher who's doing the data prep, and then a project lead who's responsible for crafting the report. We do know, as we mentioned earlier, that some of these data are PII, so we need to be aware of that when we think about our security. Some of the data is classified. I don't know why NASA data is classified. Maybe the NASA folks can tell me. But some of the data is classified. You can just think of that as an additional handling restriction imposed there. And then you are going to have a group of peer reviewers who are going to need to access the data as part of their review of the technical report that comes out the end. So how are you going to manage their ability to access the data when needed? So those are the questions you want to answer with your groups. What we'd like you to do is briefly describe how you're going to control access, how you're going to use your own infrastructure to secure the data, and how you're going to approach controlling data access for technical reviewers of that report. And then finally, how you're intending to preserve any artifacts once the analysis is complete, because you may want to have those at the end, and you may want to make sure that those are secured properly. So jot down some responses for that. Take about 5 minutes on that. We'll get back together and discuss as a group.
All right. So let's talk about securing our data and how we're going to think through that process. So the biggest question with data security, at least in my mind, is that first one up there. How are you going to control access to the places where your data live? Like what mechanisms are in place? And part of that depends on the infrastructure that your organization has in place. That's often what we use. We think about that. But one of the questions we want to ask is that infrastructure up to the task at hand? Or do we need some other additional solution? So does anyone have any answer to this first question of how we're going to control access to the data that we have once we've acquired it?
Graham doesn't want to give anyone access. I don't know if you saw that.
AWS and permissions.
So AWS permissions, how does that work? Talk me through it.
So you just assign permissions to individuals or groups of individuals.
Who assigns the permissions?
That's a good question.
Yeah,
I just know what happens in the system.
So you can have, so some people have like an IT department. Maybe it's someone who is designated to your organization by AWS. Maybe it's someone in your organization who does the AWS management.
And they can add and remove permissions for individuals. One of the key things you want to think about if you're taking that approach is how can you, as a lead researcher or a lead data steward or whoever has that responsibility, how can you maintain that situational awareness of who is on that access list? Depending on how your organization has it set up, that may be totally transparent to you, or it may be totally opaque to you. And you may need to reach out and contact that individual who has the administrative privileges to add and remove access, and periodically say, hey, by the way, who can access this? So, relatedly, what did you do with the technical reviewers?
You got a thought?
Oh, sorry.
I was just gonna say, you kind of need a two-key system also, though, because who's gonna tell that administrator who is okay or not? You can't just have anybody say, hey, add Joe.
How will they know if it's a legit request? That's a great point. So you need to make sure that person knows who that data steward is, who that individual is. And of course, you also need to be mindful of things like single points of failure, avoiding that. Because you never want to be in a situation where where the project team is unable to execute the project because the one person who can turn the key is on vacation in Cabo or something. So that's right.
Or like resign with the password or something.
Well, that's
That's happened.
you're not wrong. So thinking through how those privileges are managed, what options your organization has, very important. What about classified data? What about data with special handling privileges? What are you doing in those cases? Anyone?
Air gap.
So you can have air-gapped systems. Sometimes that infrastructure that is capable of processing data with those additional handling restrictions like classification requires an air gap. Sometimes an air gap is a really good way to secure those data and make sure that other people can't access it without logging directly onto the system. Are there any other options that we have?
Yeah, we have over here, we've got a zero trust multi-facility.
So that's a great option if you can set it up, if you got the funding. That type of infrastructure. It's NASA, right? We got tons of fun.
Encryption.
Encryption is great. So transmitting data with encryption, make sure it's encrypted at rest. That's a good way to guard against the kind of shenanigans we've seen recently where people can exfiltrate data in mass. Of course, if people have proper privileges, sometimes that is not even going to save you there either. But encrypting data at rest is a really good practice. And it's probably going to be required by your IT department if they have their stuff together. In the interest of time, I'm going to show our thing really quickly, but does anyone else have any thoughts before we press forward on any of these questions about data security?
Well, I would just make a comment. If we're answering these from a research perspective, I would say the project manager needs to either be in charge of who has access to the different folders and data subsets, or needs to designate a data manager on the project to manage all this stuff.
I agree, Bill. And I think
DBA, there is DBA. Database administrators, they are the one they are assigned the privilege. Without their approval, it cannot go. And that depends upon the CDO or whoever is in the organization, and the top person makes that determination who can get access to what areas.
so. That's a very common model for restricting access using having a class of DBAs that are responsible for doing these sort of privilege elevating and designating. In Matt's opinion, a good model is to be able to do this mechanistically and encode within some record of the project and within some system who those people are, and enable people that the system recognizes as a project leader or as someone in charge, allow them the capacity to make those changes and control that in a transparent way. That's something that I think is a good practice, because in a lot of cases, especially in the research context where I live, the PIs, the people doing the primary work on the research or leading the project, they're the ones who best know who needs to see the data and who needs to have access to it. So giving them that direct ability to control that and have them be able to see it transparently is very valuable in that context.
Yeah, so there are three people involved: the security officer, the data officer, and the legal officer. So they all three together determine actually. And I think the legal is the one that controls the
So-
based on the contract and the policies.
I think exactly how you secure data and who has access and how you think about that is determined to a large degree by the nature of the work that you're doing and the structure of your organization. So you'll see, for example, from what we've put together, that those three people would not be the most appropriate people. I would not be the most appropriate person at IDA to determine access to data for a specific research project. That is my view. But I am the appropriate person to decide how we're gonna figure that out. But in other organizations, the CDO is the appropriate person, right? So I think that's gonna take a little bit of thinking on your part. But okay, you'll remember we have a table that has a whole bunch of information in it, like these data sets, which should look familiar to you. We have a location, we've just added some extra information there. So instead of just linked to a folder, we're linking to a folder on Zipper, or we're linking to a folder in our PII enclave. We have an enclave for PII here, and we have different kinds of networks. And so where on which of those networks can this data live? We're going to control access to our unclassified and classified project team folders through a system that we have here called the project fact sheet, which is something that our project leaders, the people who are actually running the projects, the research projects, will be able to go in, enter who should have access. That then gets approved by different levels of management, but then they can dynamically add and remove people, and that will affect the access to their specific data on different networks. We've put links to where our folders are, which is where our data resides. Not all of our links will work, obviously, but it's something to keep our team in the loop in case somebody doesn't know where it is.
Think of that as a directory address, so that if someone wants to go find it, they know where to go look on what system.
That's right. And then we're going to govern our data, our PII data, according to the established protocols. We're not making up new protocols. Protocols exist. We're just going to leverage those. And then we're going to, remember, we have those people who are going to review our analysis. We're going to have to think about access for them, right? We call them technical reviewers here. And we're going to allow our project leads here at IDA to grant access for limited periods of time through the project fact sheet to those folks. This is actually a coming attraction. For people who work at IDA, they know that they don't actually have this capability just yet, but this is a little visioning from me. But what this looks like for your organization might not be, it might not look just like this, right? But writing that down and having some thought go into it is really important for your data management.
And on that last point of access, you can anonymize the data so that they don't need to know which astronaut it was.
That's right. Right. There's things we can do on the PII side to yank some of that data out of our enclave by anonymizing it and scrubbing it.
Okay. Data organization. So how are we going to organize the data we have? And now, at this level, we're not talking about how we're going to organize data within an individual file. At least that's not the primary focus that we're thinking when we're talking about our data management plan. We're thinking about how are we going to organize data on our systems. So if you have a simple flat file and you have a series of flat files, that's how you're storing them, you'll want to think about things like names for your files and folders. You'll want to think about the way those directories are going to be structured and nested in. You want to have it to be easily navigable and intuitive, so if someone finds themselves in there and they want to know how to find the specific data set, they'll be able to easily explore and navigate it. That's the idea there. But this also applies if we're talking about, for example, designing a relational database to house your data. You want to name your tables intuitively. You want to make it so that folks can find their way around the database, understand the joins intuitively, and be able to figure out how to create the data that you want. You may want to have things like README files to help people navigate that. And of course, if you're using a non-relational system, the same type of thing applies, except you're no longer talking about relational stuff. So for our scenario here, we're going to get data that comes in over multiple days. So it's not just one big file, it's multiple days. We get raw effectiveness data on human performance from multiple systems, and different team members are probably going to be processing that. So the performance data from prior test events, as well as the data from the current rover is coming in, and we have Excel files for most of this, but we're also getting an actual database that has the historic M&S data. So you are getting like a SQL style database there. And then you get a bunch of documents. Remember, we're getting employment concepts as part of our information to help us understand whether the system can perform the way we want to. So those are just PDFs. So we have all different types of formats, and it's coming in different ways at different times. So how are we going to organize the data that we get on our system? And for the purposes of today, let's just assume that you're taking this and you're putting it onto a hard drive. So we're not taking this and transforming it into something more complex than that for today. We're just taking the files as we get them and organizing them locally. So for your work together, concentrate on these first two unless you're really ambitious. Try to design an easy to navigate directory structure to store the data. Think about your naming conventions for the data files as well as the documents. You want people to be able to understand where these things live within the structure. And then if you want to try to design a database schema in your short, let's call it 4 minutes, because we've got to get you out of here by 4:50 so you can get to the fun stuff. All right, let's talk about naming conventions. The thing I love about naming conventions is there's no one right answer, and at least in my experience around here, if you talk to 3 different people, you'll come up with 8 different naming conventions that work. So the key is that you decide on one and go with it. So but let's talk about this. So what do we have for our directory structure? Who's got a rough outline of what a directory structure would look like?
I saw a picture of a spider back there.
Yeah?
It turned into a
You want to talk us through that, Bill?
Sure. So the lower half. So at the top there's a project name folder, one big folder.
There you go.
And then underneath it we have subfolders by data type. Data type 1, data type 2. So one might be called effectiveness data, one might be called
You might be a plant.
availability and maintenance data. And underneath that, we have little subfolders for like each day of testing or each day of data. So it might be Monday, Tuesday, Wednesday, Thursday, or whatever you want to call it. And then underneath that, we just have individual file names that like start with the date, and are followed by underscore, name, a type, and then the file extension, something like that.
So I'm going to touch on a couple things that Bill pointed out here. First off, under the main directory, he has different data types. I think if I got this right, Bill, these are the names from the metadata table that we built, or excuse me, the initial data planning table that we built earlier on. I think that makes a lot of sense to organize your data in your directories in the same way that you're organizing in your planning. Now, you may change your plan when you start thinking about actually populating this. And so, this doesn't have to succeed the initial plan. You could change your data management plan when you have a better idea about how you want these organized. I think embedding metadata in the file names can be useful. So in this case, Bill's putting in the dates of when the data was collected. Now maybe that's part of the actual data you have. Maybe when you open up the Excel file or the CSV or whatever, it says when the data were collected. Maybe it doesn't. If it doesn't, that may be the only record that's directly embedded with the data of that piece of information. So that's a very useful way to do that.
On the date thing, you have to operate on Mars time.
Yeah, that's right. Because we're doing the testing on Mars.
Oh,
That was the point that was brought up earlier.
Oh, that we're testing on Mars. That's a fun TDY.
Well, that would be in the data dictionary, Bob.
That's why we have the Space Force, right?
Yeah. So we have an example that we can show that looks startlingly like this. But does anyone else have any thoughts on building out an intuitive, navigable data structure or naming convention?
Yeah, I like the date thing. I would even use the international standard. I forget what the organization called, but there's an international standard. I want to say it's 8406 for exactly how you format the date. I would also add on to the variable name or as appropriate the file name, the physical units that are used, right? So if it's distance, is it meters, is it feet, just throw that on there.
Yes, if you have some primary metric that a particular data file is associated with, it can be nice to put that right up there. And that goes to one of the things that I try to think about when naming things in general. You want to try to strike a balance between human readability and machine readability with those, because sometimes someone will want to go and run a little crawler through all your files and try to parse out exactly what each file corresponds to. And if your file names and your folder structure are embedding information in there, and that can be captured in a machine readable way, but you don't want to sacrifice a human's ability to read and navigate those files. So that's not always an easy balance to strike, but I think that's one that you can hope to achieve.
Question. So I've pretty much only received data in sets per day. So I get Monday's data and 5 different file types, for example. Would you recommend keeping it in that format and changing your plan to match, or changing the format you receive it to match your data plan?
I would recommend taking the data as you receive it raw and making sure that's locked down in cold storage unmodified, and then modifying that data into a structure that is workable for your analysis.
Yep.
In terms of how your data management plan describes it, I think it's fine to say when you're getting raw data from a third party, we don't have control over what it looks like when it's initially generated. I think to the largest extent possible, you're going to want to just reflect what they're providing you, as opposed to, but then you can then say, and then we modified it in this way to make it, like, because maybe you're going to want to combine all these things into one large file for your actual analysis, right? You would just describe that and maybe point to a script that did the combining for you, something like that. Did that? Yeah. Okay.
I think Bill already showed you this.
It wasn't formatted nicely.
I don't know how much we need to get through it, but we have a top level structure with a name. America is our program that we're working with. We're going to add a README file to help people navigate our directory. We're going to have some admin materials, and maybe our data management plan is there, and maybe there are various versions of our data management plan, so perhaps we should have had a folder and not just a file there. And then in addition to the admin materials folder, we're going to have a data folder. You can choose to do this in several ways, but we have broken out our data from our analysis and our drafting of our reports. But you might choose to do that differently. I like it this way because then I have all my data in one tidy little place. But then underneath my data folder, we've broken it out by the kind of data in our data management plan table, just as Bill intuited. And we have a place for our raw data and our curated data and our archived data. We might choose to further break that down by event date. This is all going to depend on how you're approaching the analysis, right? The organization's going to look different for you. You should just document that, what the organization is, right? So that will help with lots of things like continuity across your team. If people are coming and going, you're onboarding new team members, will help them do that faster. And it will help you understand what you did a year from now. Yeah.
Maybe a little naive, but what's the difference between curated and archived data?
So this is like when I've cleaned my data, I've selected down to just the columns I need, etc., right? Archived is like, I'm done with this data, right? I'm just going to move a copy of the final thing that I use, that I'm going to use to generate, for example, an analysis. I might move it to this directory.
You don't just endlessly tweak the analysis forever.
Or you could endlessly tweak the analysis forever, and that folder could be empty.
Yes. So what is the policy? Do you archive the raw data, or do you archive the curated or transformed data?
We have, our policy is to keep a copy of the raw data as README only, and we put that in a raw data directory.
So,
but we also want the data set after you've transformed it, that type of analysis.
Yeah, and I would say if this were my directory structure and I was using this for my analysis, this is where I might have, data products that I wasn't sure I was going to use for anything. This is like, I'm just cleaning this, and then it turns out I'm not going to use that in my analysis. So that might end up there for a while, but I wouldn't necessarily put that in the archive folder unless that ends up in the actual report or some product I create.
I'm just curious, what's the value add of having the numbers in front, the 0, 0?
It's a great question.
This is for sorting. So, you know, in a file directory, if you just put it in there, it'll come in alphabetical order. That's fine. You can do it like that. I prefer to have all of my things show up in the order that I want them to show up every time. And the way to do that is by putting numbers in front of them.
That's especially useful if you have consistency across different projects. So for example, maybe if this is just a one-off, maybe it doesn't matter as much because alphabetical is fine. But if this is like project 1 and I have project 2, 3, 4, 5, and I always want these folders to show up in this order, having those numbers out front gives me a way to make it so they always look the same. So I just have a little bit more consistency.
Just a cognitive shortcut, right? I know that these files will always be in this place, no matter what. Doesn't matter who adds what.
You use the term data product. Are you guys using data mesh architecture?
I'm using data product very broadly, as in anything produced from data that will be used as data for some
A data
analysis. Yeah, data artifacts.
So got it with the numbers. What about with like the capital letters? Do you see a utility for having capital letters?
Human readability is all.
That's it.
Human readability.
All of those things are to make it easier on human beings to navigate the directory structure. It's not about the machine.
I would say this. I've had people that want to have, regular human capitalization, people who want to do all lowercase, camel case, snake case, whatever you want.
Be consistent.
Just choose one and be consistent throughout your project. That's the key.
Yeah, well, I mean, I kind of want to eradicate like capital letters, but I'll tell you why, right? Because it's easier if I just know that every file name, that every variable is always going to be lowercase, right? So that's what I do in my own work, and it also makes it easier for me to search, right? So I like to work in a Unix command line environment, right? So it's really helpful if I can just plug in lowercase n and then tab to see what's available right there in that directory, where then I don't have to instead do it twice. So for automation's sake, I think lowercase.
So I think everyone will have their own preference on what matters more to them. I'm coming from a human factors background. The human ability to navigate is very important to me in that file structure, at least as important as the automation. But other people may have different preferences. So I think the point is, go with your preference if it makes some sort of logical sense, but write it down.
I'm sorry, one more. Do you think that file names and directory names should be Unix compliant?
That's a choice.
That's a choice.
Well,
there's a choice.
If you don't make it Unix compliant, then you just broke your file structure for the majority of the world's computers.
Okay.
That's true. You may have also allowed users to implement a consistent plan for that project in a way that was both sufficient and consistent.
I think we're pretty in the weeds right now.
So the point is, these are all choices.
That's right.
And we're running out of time. We only have a couple more minutes.
And metadata can save the world, so we got to get to this.
Really briefly, when you think about metadata, we talked a little bit about this earlier, so I don't know that we have to go too far in depth here, but we think about information that you need to collect about your data. That includes all the information about where you got it. Contextual information is very important here because that's going to have a bearing on what you can use the data for in the future and what some party in the future who may want to discover and use that data for something else, how effectively they'll be able to do that. So in addition to what metadata you want to collect, where are you going to collect it, how are you going to prioritize that? We don't really have time to walk through the scenario. We'll just show you what we did here. Tables are nice.
So this will evolve, should evolve with the new CDAO guidance. They have, I think, 10 or 11 pieces of metadata that they want everyone to start collecting. So we'll be modifying our own practices for that, but you can see this is pretty basic. Where'd you get the data? Who'd you get it from? Try not to trust these two data sets. And then, of course, where is it stored? When was it received? Do we have any supporting documentation? So in this case, that might be things like test plans, temps, data dictionaries, other assorted things.
Yeah, I think it's important to recognize supporting documents it's not limited to a data dictionary or a README. This is any other information that helps contextualize the data that you want. There may be good reason to keep that data and make sure there's a clear linkage from your data set.
Architecture,
Yes.
requirements document, could be anything that matters here. And you can add certainly more than this. Like we have research areas, for example, that we may want to tag as part of our metadata.
Keywords.
That other people might not. But I think this is about half of what the CDAO has recommended that we collect.
Matt, you used the word context.
Yes.
Which is really important to understand the numbers that you're looking at.
Yes.
Another word you could use for that is conditions.
Yes.
And there can be a long list of conditions, you know, day, night, whether there was wind, et cetera, et cetera, et cetera.
That's right. Mm-hmm.
Should you capture all of those, or is that a separate thing?
So that's a question of, so there's two things. Sometimes those conditions are a part of the data themselves from a test event, for example. Other times they are observations or they are captured in a separate data set. So for example, you may, in your supporting documents you may have like a directory with weather reports for each of the days that you test. So that's where I would describe that. And in terms of what extent you need to collect that information, that depends on the data and your use case. So there's never going to be a one-size-fits-all answer.
Well, okay, that makes sense, but you picked out one, like location there, that could have just as easily picked out other ones.
Yes, it could.
This is the location of where the data exists. But yes, it could be, also you should be careful naming the column. But yes.
Directory location.
So you have a metadata table stored somewhere.
Mm-hmm.
Files can also have their own metadata, though it's surprisingly difficult to edit most of the time.
Mm-hmm.
Do you propose that we should be tracking that level of metadata within a file? For instance, when a picture was taken is a common piece of metadata, but there are many types of metadata files can have.
I think
Should we get to that level?
I think it depends on your use case. Unfortunately, there's not a great answer to that. I mean, from my view, this is something that the community is starting new. And for some programs, it's going to be really important that you get down to the time or date stamp of every picture that was taken. That's going to really matter. In other cases, it's not going to matter at all. And so I think you have to make some judgment about what's meaningful for your analysis and for the searchability of these data sets in particular in the future.
So there's also, what are you requiring be generated with the data?
Yeah.
Versus what are we trying to capture? So if you have that information embedded in the image already, do we need to surface it here? Maybe, maybe not. But if I do need that information and I'm expecting it to be embedded within the data file itself, then I need to make sure that at the collection point, that metadata is going to be collected there.
So I think we're over 4:50.
Oh, yes.
So I think we have to let these folks go, but you have this scenario. We talked a little bit about reproducibility before. We think it's really important that you be able to reproduce your analysis for lots of reasons, for the rigor of it, for your ability to defend your analysis if you need to, as well as for review purposes. There are many cases where I can imagine that people might have disputed the choices that folks made as part of their analysis, and the ability to document those is pretty invaluable. So we use all sorts of tools to help us with reproducibility, scripting if you can, version control, things like Bitbucket, Git, really useful.
We had a Git tutorial last year at DataWorks. You can see it on the DataWorks archive if you want to go back and view it. It's online. So.
Otherwise, we will let you escape and I'll hang around for some questions. Thanks,
Thank you all.
everybody.